The Space Shuttle Challenger, a name synonymous with both triumph and tragedy. The Challenger was not just another spacecraft, it was a beacon of hope and a symbol of human aspiration. Its missions were followed by millions around the globe, each launch a testament to what humanity could achieve when it dared to dream big. A symbol of human ambition reaching for the stars and a stark reminder of the risks inherent in exploring the unknown. The Challenger's missions were a blend of scientific exploration and human courage, pushing the boundaries of what was possible and inspiring generations to look up and wonder. Challenger, one of NASA's fleet of reusable spaceplanes, captured the world's imagination with its daring missions and the promise of making space travel more accessible. Each mission was a step towards a future where space was not just the domain of a select few, but a frontier open to all. Before Challenger, space travel was the domain of highly trained astronauts, a select few chosen from a pool of the best and brightest. These pioneers paved the way, but the Space Shuttle program aimed to democratize space, making it possible for scientists, engineers, and even teachers to journey beyond our atmosphere. The Space Shuttle program promised to change all that. It was a bold vision, one that sought to transform space travel from a rare and dangerous endeavor into a routine operation. The shuttles were designed to be reusable, reducing costs and increasing the frequency of missions. These reusable vehicles were designed to make trips to low Earth orbit more routine, more like taking a commercial flight than launching on a perilous journey into the void. The idea was revolutionary, promising a future where space travel was as common as air travel. Challenger, the second space shuttle orbiter to be built, embodied this spirit of accessible space exploration. It was a marvel of engineering, a complex machine designed to withstand the rigors of space travel and return safely to Earth, ready for its next mission. It was a symbol of American ingenuity, a testament to the power of human innovation and collaboration. The Challenger's construction involved thousands of engineers, scientists, and technicians, all working together to create a vehicle that could carry humans to the stars and back. From its inception, Challenger was destined to be different. It was built with the lessons learned from previous missions, incorporating new technologies and design improvements that made it more capable and reliable. It was built using structural spares produced during the construction of Enterprise, the first orbiter, which was used for atmospheric test flights but never intended for space travel. This unique aspect of its construction gave Challenger a distinct advantage, making it a more advanced and capable vehicle. This unique aspect of its construction made Challenger a sort of second-generation orbiter, incorporating lessons learned from the development of Enterprise. It was a vehicle designed for the future, ready to take on the challenges of space exploration and push the boundaries of what was possible. Little did anyone know that Challenger's journey, filled with moments of exhilaration and groundbreaking achievements, would also be marked by profound tragedy. Its legacy is a complex one, a story of human triumph and loss, a reminder of the risks we take when we reach for the stars. Challenger's construction was a marvel of engineering, a testament to human ingenuity and collaboration. The project brought together some of the brightest minds in aerospace engineering, all working towards a common goal: to create a reusable spacecraft that could revolutionize space travel. The design and construction process was a massive undertaking, involving thousands of engineers, scientists, and technicians. Each team member played a crucial role, from drafting initial blueprints to assembling the final components. The collaborative spirit was palpable, as everyone understood the significance of their work. Rockwell International, a company renowned for its expertise in aerospace technology, was tasked with bringing this ambitious project to life. The shuttle's design was revolutionary for its time, a reusable spaceplane that could launch like a rocket, orbit the Earth, and glide back down to a runway landing. The orbiter, the part we typically picture when we think of the space shuttle, was just one component of a complex system. The entire shuttle system included the orbiter, 2 solid rocket boosters, and an external fuel tank. 2 solid rocket boosters, fueled by a mixture of aluminum powder and ammonium perchlorate, provided the initial thrust needed to escape Earth's gravity. These boosters were designed to be jettisoned after their fuel was spent and then recovered and refurbished for future missions, making them a key component of the shuttle's reusability. A massive external tank, containing liquid hydrogen and liquid oxygen to fuel the orbiter's 3 main engines, was also crucial for a successful launch. This tank was the largest single component of the shuttle and was jettisoned once its fuel was depleted, burning up upon re-entry into the Earth's atmosphere. Challenger's construction involved countless hours of meticulous work by skilled engineers and technicians. Each phase of the construction process required precision and attention to detail, from the initial welding of the frame to the final installation of the avionics systems. Every weld, every wire, every component had to be perfect, for even the smallest flaw could have catastrophic consequences in the unforgiving environment of space. Quality control was paramount, with rigorous testing and inspections conducted at every stage to ensure the shuttle's integrity and safety. The orbiter itself was essentially a giant, complex flying machine, equipped with advanced avionics, thermal protection systems to withstand the searing heat of re-entry, and a spacious cargo bay capable of carrying a variety of payloads. This cargo bay was designed to accommodate satellites, scientific instruments, and even modules for the International Space Station, showcasing the shuttle's versatility and its pivotal role in advancing human space exploration. April 4, 1983, marked a momentous occasion in the history of space exploration, the maiden flight of the Space Shuttle Challenger. After years of meticulous design, construction, and testing, Challenger was finally ready to take its place among the stars. The atmosphere at Kennedy Space Center was electric with anticipation as millions around the world watched the launch on live television. The roar of the engines, the vibrations shaking the ground, the blinding flash of light as the solid rocket boosters ignited. These were the sights and sounds of history in the making. On board were astronauts Paul Weitz, John Young, Carol Bobko, and Story Musgrave, the first crew to pilot Challenger into the unknown. The mission, designated STS-6, lasted 5 days and was deemed a resounding success. Challenger performed flawlessly, deploying the first Tracking and Data Relay Satellite, TDRS, a crucial component of NASA's space-based communication network. This successful maiden voyage marked the beginning of Challenger's illustrious, albeit short-lived, career. The journey to this historic day was not an easy one. Engineers and scientists spent countless hours perfecting every detail of the shuttle. From its powerful engines to its sophisticated onboard systems, every component was meticulously crafted to ensure the success of the mission. The shuttle's intricate systems and control panels were a marvel of modern engineering, representing the pinnacle of human ingenuity and technological advancement. The astronauts themselves underwent rigorous training, preparing for every possible scenario they might encounter in space. Simulations of space missions, emergency procedures, and countless hours of physical and mental preparation were all part of their journey. As the launch day approached, the families of the astronauts gathered, their faces a mix of pride and anticipation. They knew the risks involved, but they also understood the importance of this mission for the future of space exploration. As Challenger ascended through the atmosphere, breaking through the clouds, it carried with it the hopes and dreams of a nation. This was not just a mission for NASA, it was a mission for all of humanity, a testament to what we can achieve when we dare to dream big. In space, the shuttle orbited the Earth, providing breathtaking views of our planet. The mission's success was a reminder of the boundless possibilities that lie beyond our world, waiting to be explored. After 5 days in space, Challenger returned to Earth, landing smoothly on the runway. The mission was over, but its impact would be felt for years to come. The success of STS-6 paved the way for future missions, each one building on the achievements of the last. Celebrations erupted at NASA as the astronauts were welcomed back as heroes. Their bravery and dedication had made history, and their mission had opened new doors for space exploration. The legacy of Challenger would continue to inspire generations to come. Section 4. A runaway success, early triumphs of Challenger. Following its triumphant maiden voyage, Challenger quickly established itself as a reliable workhorse of NASA's space shuttle fleet. It flew 9 successful missions in its first 3 years of operation, demonstrating its versatility and reliability. These early missions were crucial in proving the shuttle program's concept of reusable spacecraft. Challenger deployed numerous satellites, conducted scientific experiments in the unique microgravity environment of low Earth orbit, and even carried the first African-American astronaut, Guion Bluford, into space on STS-8. Each mission pushed the boundaries of space exploration, expanding our understanding of the cosmos and our place within it. One of Challenger's early triumphs was its role in launching the first Space Lab module, a reusable laboratory developed by the European Space Agency. This marked a significant step towards international collaboration in space exploration, paving the way for future joint ventures like the International Space Station. Section 5. Pushing Boundaries, Notable Missions and Achievements. As Challenger continued to rack up successful missions, it became clear that this space shuttle was destined for greatness. Two missions in particular stand out as testaments to Challenger's capabilities and the ambitious goals of the Space Shuttle program: STS-41G, the first commercial satellite launch, and STS-41D, which carried the Long-Duration Exposure Facility. The deployment of the first commercial satellite, a communications satellite for the company's satellite business systems, marked a turning point in the commercialization of space. It demonstrated the potential for private companies to utilize the unique capabilities of space-based platforms, ushering in a new era of commercial space ventures. STS-41D, on the other hand, showcased Challenger's capacity for scientific research. The Long-Duration Exposure Facility, a 12-sided structure packed with scientific experiments, was designed to be exposed to the harsh environment of space for an extended period. It carried 57 experiments from various institutions, studying the effects of long-term space exposure on materials, coatings, and living organisms.